Okay, sometimes it does a countdown, sometimes it doesn't. Sometimes I feel like a nut, sometimes I don't. Anyone know that commercial? No, they don't. All my references, old and decrepit. Okay. Get my fat head in the corner there, and I'm ready. Shirt. Okay. All right, now polynomials. Can everyone say polynomials? Okay, so this is so stupid. And actually, we just did this in the other my BCers. What the heck is this? A's, N's, X's, and N's, and then minus ones, and all this other stuff. Let's just focus on the first X's, and then that says X to the nth, and then this says X to the n minus one. All it means is that next term has a smaller degree than the previous one, right? So the top dog degree is the X to the n term. That's the one that has the highest degree. So the degree of this polynomial is n up there. Sorry if that n looks bad. This pen is better. I can't really touch my screen. It goes all haywire. Anyway, and then what is a sub n? Just the leading coefficient. That's it. So that's the leading coefficient there. So it's just some number. They're just writing it in math terminology. And that's the one you want to key off of for a polynomial because it dictates a lot of stuff. Now I'm going to tell you the why. A lot of kids don't care, but you should care. So then there's a better understanding instead of just grasping at an idea and memorization. All right. So I'm going to tell you why what happens next does. And actually, I might break into it right now, not break dance. Can't do that. That's the whole thing. Anyway. So here's what's going to happen. Oh, wait, I think I'm jumping ahead here. So here's the thing. What is the degree of this polynomial here? Well, who's the top dog here in this one? X to the what? 3, 2, 1, go say it. 6. Okay, so the top dog is right here. It's negative 8x to the 6th. Don't ignore the minus sign. Okay, so first of all, it's 6. Sorry, that's the degree. Then what is the leading coefficient? Negative 8. And then I'll go to the next part with the definitions of what's happening here, which may or may not be the best looking pictures, but they are. I think they're actually okay. Here's what you need to know, and I'm going to tell you the why. And if you don't care, that makes me sad because there's actually a very simple reason. Input, say it. It's input output idea. If I had an odd degree, and then you highlight what you want so you see this, and the leading coefficient was positive. That's what this says right here. Then your graph would end like this. In the middle, this is why this is dotted. It's arbitrary. It depends on the degree. If it's x to the third, x to the fifth, x to the seventh, then you might have more roller coaster, more fun. All right, but definitely the ends are what they are. Here's why. Let me throw an example here. Let's say it's like y equals 3x cubed. I don't care if it was minus 1000x squared plus 2x minus 1. I just wanted to. When I plug in large numbers, okay, let's say I plug in 1. If I plug in 1, that's just 1 cubed, and then 1 squared times this negative 1000 is the biggest, it's going to be a negative output. You should at least understand that, right? Right? If I plugged in 1 for x, just go like this. Okay. But then as I plug in bigger numbers, the cubing starts taking over. Like when I plug in 1,000 cubed compared to 1,000 squared, this is much larger. As a matter of fact, that flips this to a positive output, the number that I just picked there. I know it would. So that's the idea. As I plug in large numbers, the cubing takes over and my output becomes positive as I plug in large numbers. Now, I asked this first hour, I think they were comatose. What's a negative cube? Just what's the answer? What's a negative cube? 3, 2, 1, go. No. What's a negative cube? No, a negative cubed is negative. So what happens when I plug in negative large numbers, which is actually smaller numbers? The more negative, the more smaller it is. Then a negative cubed becomes a negative, and that dominates. So on the other end, my outputs are negative when I plug in big negatives. As I move to negative infinity for x, this is where y goes. So this is guaranteed what an x cubed is going to look like. By the way, you math 3ers, you should remember this. This is something you did last year. Math 2 honors, absolutely. You should remember that as well. We did that at the end of the year last year. Okay, so no two ways about it. And then what happens when there's a negative leading coefficient? Well, it flip-flops. Because a cubed positive is huge positive, but then I throw a negative on it. Boom. A cubed negative is negative, but then I throw a negative on it, and it flips it to positive. Right? So that's why this is the case for this. I mean, come on. For even degrees, we already had this. We already had a quadratic. You guys were better at quadratics this year. I still got some people that can't graph. Ugh. Okay, you're either going to do something about it or not. You're severely and totally behind, though, if you don't know how to graph a quadratic. But knowing a quadratic, this is a right? Positive leading coefficient quadratic, and then a negative leading coefficient. That's easy. Okay, now starting with the dance. Here's a positive x cubed. Here's a negative x cubed, right? We just did that. And now an x to the fourth that has a positive. Why? What's a negative raised to the fourth power? What's a negative raised to the fourth power? 3, 2, 1, go. Positive. So as I plug in big negatives, the outputs become positive. The x to the fourth takes over. And of course, a positive to the fourth. Right? And then if there's a leading coefficient that's negative, it flips down. So here we go. Let's start over. X squared, negative x squared. X cubed, negative x cubed. Positive x to the fourth, negative x to the fourth. Then you start getting swaying in it, and then that's your polynomial dance. Got it? Mm-hmm. She's shaking her head. Okay, homecoming, 2 weeks. Better see it out on the floor. Okay, anyway, so when A is positive and A sub n is negative, you get the flip-flop polynomial dance. You're already doing it. Go White Sox. I love the faith. We are going to do it, man. We are making history. They have lost how many games in a row? 13, 14 already? They have 3 different losing streaks of like 12 or higher. No team has ever done that. All right. Go White Sox. Okay, now, so what's the end behavior of our given polynomial? Hopefully I have enough time to do all this. What's the end behavior? Well, this is this kind of weird thing. Is it A? Would it be like this, and then little loops, and then end up and up? Or would it be B, little loops, and then end down and down? Or like this? Or like this? Okay, class, which letter is it? A, B, C, or D? 3, 2, 1, go. Oh, no. It's an even, so it should either be up and up or down and down. So C is not an option. So which one is it? A or B? B. Okay, B. All right. Got it. All right. We're going to get into other end behavior and appropriate language later, so this is all good. Okay. Oh, I really made a mistake. I think I'm going to make the same mistakes that I made first hour, or at least one of them. So on this first one, I'm just going to do relative extrema. The idea of relative compared to absolute. Now, math 2 regulars, you're going to have a lot of, you better pick this up quick, okay? Because that's just the nature of the business. You came from a class that went really slow to a class that we're taking an AP exam. You're in an AP course. You got to pick this stuff up quick. All right, but the idea of relative and absolutes. Okay, so it looks like the same picture, but I'm just going to mark the relatives here and then make some adjustments from last year on the notes. So here are relative extrema. So this one right here comes over here. Why is that absolute maximum? Because absolutely that is the highest y value, correct? Correct? You see that? Okay, so that's why that's over there. So I'm going to ignore it on my relative side. Here is a relative max. And I want to get to where that is, relative max at. So I have a relative max of is the y, x is the where. Input, say it. This is kind of like input-output language. The where is the input. I plug in -2 for x. Apparently I get 1 for an output. Locally speaking, in that little area, that is the highest y value. But globally, it's not the absolute maximum of this graph, this particular one. And then right here, wait, we have this too. We have a relative minimum, and you don't have to put these in any order here. It's just got some sentences here. Relative minimum value of -1 when x equals 0, right? So knowing that coordinate, it's coordinate language. And then you got to be careful. Is that a dot or an arrow? Does that mean it ends or it goes forever? Ends. So this one I made a mistake, but I'm not going to make the mistake this time. I actually made a mistake about saying something about, oh, wait a minute. So that's the mistake. Is that a relative minimum or an absolute minimum? What is that? 3, 2, 1, go. That's what I did last hour. And I put it over here. So let's go ahead and put it over here. Absolute minimum value of -3 when x equals -4, and then mark yourself wrong. Why? Does anyone know why? Look at the picture. Yes. Where, what do you see? It starts with an A. AR. Darn. Do you know what I'm saying? There's an arrow. So you said it goes down. I just want to know why. I think that's what you were saying. That killed it. And I accidentally did this last hour, and I'm like, oh no, that arrow implies that that goes forever down, which takes over the lowest value from that one. So that doesn't belong here. It belongs here. It's a relative minimum because it's not absolutely the minimum. All right? I really got to watch my language on this too, some other things. Watch your language. All right, and then I don't want to call that a relative. I want to call that an absolute. So I'm going to kind of cross that off. This is an absolute maximum of 2 when x equals 3. So I purposely made the same mistake. I accidentally did it in the other hour. And then I made another one, but I don't want to share that one. Show my imperfections today. Okay, and then this one is pretty easy. Arrows or dots? Arrows, so that goes forever down. There is only one thing. What is it? Absolute and what? Absolute what? Max or min? Max. This kind of looks like a quadratic, which we say that all the time. So absolute max of 3 when x equals 1. I don't have anything else. So destroy. And I don't know. I think that some of the other teachers are calling absolutes relatives, and I just don't think that's quite right. We want to say the best definition of what it is. All right, and I only have that one term there. All right, then the next one I just kind of shoved in your face. All right, so go ahead and write these things down, and actually I crossed them off. This was my last year's notes, and I was calling relatives or absolutes relatives first, then adding that they were absolutes, and I don't think we should do that. Okay, dots or arrows. So this one, I really made that arrow emphatic to make it emphatic that that's not an absolute. Okay, so that's a relative minimum at x equals -2. Now this one just changes the language, just at, it doesn't say what it is. I do like this language a little bit better down here, but we got what we got. And then a relative max, -4. No, this is an absolute max, so I wanted to take that off the list there. I just called the relative one. Now be careful on dots. That does count as a relative in this case. If this dot was higher than that dot, then this would be the absolute, but it's not. And then over here, different little picture. I just wanted the relative minimum at -3. Move that down a little bit. Not -3. -3 is where an absolute is. So I moved that to absolute and I crossed that off. And then I do have a, let me make sure I got all these right. 0, -4. Yeah, I do have a relative. I almost missed that one. So that's a relative max there because of the dot thing. All right. And then a relative max also at 0. And then labeling the absolutes. I have an absolute minimum that is here of -3 at -3. And an absolute maximum of 4 at 5. Right? And that's how that shakes out. Okay, so give you a second to write that down. It's 08 in this class, right? 08?
Yeah.
Yep. Finally getting the schedule down. How long has this schedule been going? 4 years? All your life? Your whole life? Since sophomore year? Anyone know Zaworski? Sophomores. Anyway. You know who I'm talking about? It's coming up in Homecoming. I don't know if he does the microphone anymore. He might have retired from that. Okay, now, I know I have this stuff marked up, but we're using this for the next box, which I'm just going to shove the answers. You kind of got one of the answers showing right there, right? But here's what, using this graph and expectations, what things can you expect to have happen? Well, number one, a negative x to the sixth is down and down. I don't know, there doesn't necessarily have to be x-intercepts, but let's say that there are. But for sure, if I had a negative x to the sixth, which ends down and down, there is guaranteed, no matter what, in one of these humps to be an absolute max, right? I mean, come on, because it doesn't turn around, the arrows go down forever. So there absolutely is a high. If it was a positive x to the sixth, then it'd be like this. There would be an absolute low point, right? So this establishes a point for even degrees. Even degrees are guaranteed to have an absolute extrema, either absolute max or min, depending on which direction it is going. Whereas an odd degree will always be like this, which goes off to positive infinity and off to negative infinity. So no absolute. And then if it's negative leading coefficient, it just flips. So therefore, same thing. So there would be no absolutes, there would be relative extrema. So these are things we should be able to surmise just by knowing the degree of the polynomial, the lead, the top dog, that is degree. Then another thing, look at the zeros and what else you're guaranteed. Look at between these two zeros that to get from this zero to that zero, I'd have to have a turn and come back down. So another thing that's guaranteed between two zeros, there absolutely has to be a relative extrema, either a max or a min. I probably shouldn't use the word absolute, but there definitely would have to be an extrema between that. And then look at these two zeros. Between these two zeros, this would have to turn around and come back up. That means there would have to be a relative extrema between those two zeros. Same thing with this. These two zeros, I got something. I got at least some extrema there. All right? So that's why we should know the following things. Between two real zeros, there absolutely, positively, without a doubtly, has to be an extrema. I don't know if it's an absolute or relative, but I just know it's got to be there. Got to be there. And then if I have an even degree polynomial dance, x squared, negative x squared, x to the fourth, negative x to the fourth. You know, those would absolutely positively have an absolutes. Now, this is tied to this. If I have an even degree and it's a positive leading coefficient, up and up, I'd have a low point, so an absolute low. If it was a negative leading coefficient, down and down, I'd have an absolute high point somewhere because the graph extends down and down. One more time, input, say it. It's all about input output. Right? An even degree, as I plug in large numbers for x, the even degree, raising that large number to an even degree power makes the y take off. Same thing with negatives to a sixth or to an even degree turns positive as an output value because negative to an even degree is positive. So it's all about end behavior, and we're going to do that more and more. You're going to see all that stuff. All righty then. Okay, here's a AP kind of jerky question, but it's actually not that bad. So let the polynomial function of the value f of, one more time, input, say it. Output, he's saying as he's looking out the door. It's hard to not look out in the hallway with my door there, you know. Anyway, ooh, people, they have legs and they're walking. All right. So what is negative 2, the x value or the y? What's negative 2, the x value or the y? It's the x, and then what's 0? The y. Okay, so what this is saying is I have a polynomial function. Graph it, my silly little friends. So this means negative 2 comma 0 is a point. That's a 0. That's an x-intercept. So you must understand this math notation. And then what's f of 0 equals 5? What's that called for a graph? The y-intercept. I heard someone say it. Nice. And you don't have to show the tick marks, I guess. I could just put this as 5 and say, okay, 0, 5. That's a point. And then f of 4 equals 0. That means 4 comma 0 is a point. And then just one more, it says f of 7 equals -1. So that means this one. So if I were to graph this, and last hour I stopped at 5, this one I'm going to get like I'm not saying that has to be the extrema at that 0, but at least without any other information, if I connected those 4 points, I would have that part of the polynomial. What do I have for sure? Is there a guaranteed extrema between these 4 sets of points? Yes or no? Absolutely. Between two zeros, I have to have a point that comes out. I guarantee it'd be like that too. It'd be you just say yes. What are you doing? Why? Yes, I'm yelling at a computer and yelling at technology. This is AI. I think they're starting to take over and drive Mr. Samuelus nuts. Yes. Look at this. It's still going. It's still going. I can't do a simple task of just writing on a screen. Okay. Yes. And if so, state where they occur. They occur between -2 and 4. Okay. So let's say between -2 and 4. Between, I'm really bad with English, but I always worry about time. And 4x. That's the where. Always the where seems to be the x's, where the x's are located. So between those two x-intercepts, guaranteed. And then the next thing, this is piggybacking off of what we just went over previous to this. Is there an absolute, there it's going again, minimum or maximum? What's the leading degree of this one? What's the degree of it? 3, 2, 1, go. 4. So, class, yes or no? Let's see if you were listening before this last example. 3, 2, 1, go. Yes. And by the way, yes, what would it be? A max or a min? It'd be an absolute. An absolute. This goes like this because it's a positive x to the fourth. So it'd be an absolute what? Minimum. So I heard a couple people say max, and that's okay. Keep answering, and then just make your corrections. Okay, yes or no on this one. By the way, that was the reason. Yes or no on this one. Yes or no on this one. 3, 2, 1, go. Yes. Why? What's the degree, everyone? 6, but it's negative. Okay, so this goes like this. So what do I have? An abs max. I like that one. An abs max. It's my. And then the last one. Oh, good. It didn't do the thing. Yes or no? Absolute. Yes or no? No. This. Just did it again. Just did it again. Just did it again. Can't write, just drags the paper. I know there's like some solution for this, but it's annoying. And it should never happen anyway. Okay, there's a no on that one. Okay, so there's none. Got it? Simple little things here. And now about concavity. Okay? And I made a little mistake on this real quick since we're fast tracking this 8 minutes. Didn't want to talk the whole period. Now these are points of inflection. Go ahead and mark them here. These are just, I'm trying to show some tangent lines here. This was the last thing, one of the last things I did before our last quiz, that little cheat sheet that you should not lose. Increasing at an increasing rate, decreasing at an increasing rate. I did 4 different curves and described concavity and all the different components for it. That sheet should be huge and you should not lose that. Okay, but do this point of inflection as right around here, -1, -1. Because what's a point of inflection? The change of the bowl shape. This is a bowl shaping up, so that's concave up. I don't think concavity has been a problem for you guys here. Concave down right around here, so the next one's about 1, -1. Because then this looks like it switches to a bowl facing up. All right, then remember, when I did on that sheet, I did some tangent lines. Steep negative, not as steep negative. Okay, but what's happening to these numbers? Are they going up or down as far as these slopes? Who's bigger, -6 or -4? -4. So what are these slopes doing? They're getting what? Bigger. And then it gets to 0, and then it gets steeper. What? Why? Steeper, and then it starts turning less steep back to 0. So what happened to these slopes? They're getting bigger, but now they're getting what? Smaller. And then they're getting smaller. But these are negative steep, and now not negative less steep. So getting larger. and then positive, and then larger. And I threw a little slope of a tangent line here. So look at these questions, and then I'll just reveal the answers. So this just says we're going to use this. Now pay attention, because this is what that sheet had. It had differences. So what determine if the rate of change of G is, it doesn't say positive or negative, it says increasing or decreasing. This is the thing that I showed you. Those are different things. So let's look at this from 3 to 4. Let's answer different questions before I actually answer the question. From 3 to 4, what are all of these slopes of tangent lines, positive or negative? What are all these slopes, positive or negative? Positive type slopes. But what are they doing? Are they increasing or decreasing? They're increasing. Those are two different things. And I'm reiterating that because I'm not sure everyone grabbed that when we did that last little thing that I made last year that put it all together. I have the eraser. Boom. So from 3 to 4, they ask if it's increasing or decreasing, not positive. So I have to say that. Rate of change is increasing. The reason is, one reason you could use is because it's concave up in this interval. And that's what concave up actually means. I'd accept that. Hopefully AP does, and I don't think there was much of a problem with it. All right, and then that says, does that say -4 to -3? Okay, we'll go back to that because we're gonna cheat. And so from -4 to -3. Okay, listen. What are the rates of change between -4 and -3? Positive or negative? What kind of slopes are these? They're negative, but what are they doing as I move? They're increasing. This is concave up. So negative but increasing. And that's why I'm going over this one more time for those that did not get that. The difference between not negative, positive, and increasing and decreasing. Totally mutually exclusive things. Different. And then -1 to 1. Well, by golly, that's where the points of inflection were. So from -1 to 1. Okay, but what are my slopes here? What are my slopes from -1 to 0? What kind of slopes are those? Positive, and now what are they? Negative. But what are they doing as I go along this interval? They're decreasing because you're on a concave down scenario. So that even in that interval, they do both positive and negatives. But in that interval, they are always decreasing as I move from that x value to that one. And then from 1 to 2, you can look at it. It's the same. It's increasing, I believe. Right? Okay, so now I can leave that, and then you can write what you want. And then I'll end the video. Look at the light. Did she know that? Yeah, I am. She's going to sneeze again.